Alright, Mr. Claxton's algebra class. Just going to take you through a very, very brief, much more brief than the last one, overview of what we did today in class when I introduced solving by completing the square, solving quadratic equations by completing the square. Before that, I wanted to review where we've been. So I said list all the different ways that one can ask you to solve a quadratic equation. And I ended up not listing, as I ended up getting into some depth here. So we have quadratic formula, then we have factoring. I went through the special cases, which you could pause right now if you wanted to see those in more depth. We then discussed how to factor by grouping in a previous YouTube video. I explained every piece of this. If you pause right now and would like to look through it, if there's something you don't understand, I do explain it in a 12-minute video. Next, we talked about solving by using the properties of square roots. So whenever I have 3 multiplied by a quantity squared, I want to isolate that quantity squared. That quantity squared, I want to isolate that so I can square root it, because I know square rooting is an inverse operation for squaring. And that will give me 2 answers. This is the exact form. I know many of you like the rounded form, but I will ask for the exact form quite often. This is just a condensed version of the review that we did, and it explains it by section in your book. So when we have a quiz, over the first 3 sections, you can kind of see this is the Cliff's Notes version. We know that when the quadratic equation can't be factored, and we can't isolate that squared term, we can make a squared term in it by operating on both sides of an equation by completing the square. We could also use the quadratic formula, which we don't have yet, I would like to add. That comes along in the 5th section of Chapter 5. Next, we do have the steps for completing the square right here. If you'd like to copy those down, I did give a handout today to show how to do that. And I have posted the solution to example 3 as well. The solution to example 3 is actually posted in the workspace video, or it's posted on YouTube in a workspace video. Here's the work for that, if you'd like to pause. So that just kind of gives you the skinny on what we've been doing. This explains step by step, and it correlates with this right here. This is what we will be discussing on tomorrow, Tuesday. Today, I actually was just able to accomplish explaining what the process is of completing the square. To be a little bit more exact about that, I would like to show you the step that I'm concentrating on here. This always seems to be the toughest part. This is the actual completion of the square, step 3. Identifying the coefficient of the linear term. That's nothing more than the b-value. So we're just going to go ahead and write b-value there, because that's what linear term means. The linear term just means b-value. So I'm looking for the b-value there. Just go ahead and underline it. Multiply it by a half. I like to say divide by 2. Or multiply by a half. You should learn that division is the same as multiplication. And then square the result. So that's the step we're focusing on here. Understand, we're not dealing with an equation here. We're going to take this x squared minus 12x, and we're going to make that into a perfectly squared trinomial. In order to do that, we're going to add the value b over 2 squared. I can identify the b value in this example by looking at the sign in front of the 12. So I know it's a negative 12. I know I'm just going to be adding negative 12 over 2, and I'm going to be squaring that. Now the fact that this is negative, don't let that bother you. When we square it, it's going to become a positive anyway. When we add the negative 12, or, sorry, when we divide first, if we were to divide that first, negative 12 divided by 2 is negative 6. So x squared minus 12x plus negative 6 squared. And we all know that negative 6 squared is positive 36. Don't go to your calculator on that one. It might misguide you if you enter the wrong information, or if you enter that negative 6 squared the wrong way. So plus 36. We can see now that this actually matches one of those special cases that I was talking about earlier. Earlier in this slide, actually, I was talking about a special case. And if you look right here, that special case, a squared minus 2ab plus b squared. Go ahead and go back to what we were doing, so x squared minus 12x plus 36. You might think how that's going to factor, and that's going to factor into x minus 6 squared. Now understand, I could do so much more with this, and I would like to show you more about this, because there are going to be times when this is not going to represent an integer value by dividing both of those, and you will actually have to square it. The end result every time will always be a perfectly square trinomial of the form x, and because that's a negative right there, I'm going to say minus, and then 12 over 2 squared. Notice how this is, all I did here was I square rooted that negative 12 over 2 squared. 12 over 2, you know, is 6. So many people just like the quick and the easy. I often over-explain concepts in an attempt to try to get you to understand it in more depth. So that is the quick and the easy right there. I know some of us really like that, but when we get in a hurry, we have to be very, very careful. Very, very careful, because you might forget a squared term like I did right there. Down here, we're looking at x squared plus 27x. Again, I want to add the b value over 2 squared. And the quick and the easy just says take 27 over 2 squared. You know that's going to factor, because you just added that b value divided by 2 squared. You know that it's going to factor into, well, I see that's a positive right there, and I know it's a positive b, so the b value is positive, so it's going to be x plus 27 over 2, which many of you might be thinking right now, well, Mr. Claxton, why don't you just call that 13 and a half and get it over with? And I'm going to square that. Now, I want you to recognize that that is much, much different than just saying x squared plus 27 over 2 squared. What we're doing here is we're multiplying x plus 27 over 2. Okay, I'll give in. I hear you out there. I really don't hear you at all, but sometimes I like to pretend like I hear you. I'll call it 13 and a half, just for fun, right? Can't believe I just used that word. 13.5 times the quantity of x plus 13 and a half. So that's what we're looking at. In just about 9 minutes, you were caught up on class today. You now understand how to do the homework assignment, which for those of you who didn't copy it down in class, it was page 304, and we did numbers 5. It was a light homework assignment tonight. 6, and then we did 11 to 16 all. There will be more tomorrow on how to deal with factors that do not look normal, a little bit tougher to deal with. And beyond that, after that, we can prove the quadratic formula and then just move along to the quadratic formula, which I know you will all come to love and appreciate. So this is Mr. Claxton signing off on what we discussed, the beginning steps to solving a quadratic equation by completing the square, along with reviewing um, Chapter 5 thus far.